Now, as of a special interest is the case to deal with the heading orthogonal trajectories, which is a part of differential equations, of course. Yes. First of all, let us understand the meaning of the word orthogonal trajectory. And in the very beginning, what is a trajectory? Look here. What are all these? These are all straight lines. Observe this straight line. This straight line is intersecting all these lines. So it is called a transversal. It is called a transversal. Now you observe. What are all these? Parabolas are a family of curves. You observe this curve. This is a curve which intersects every member of this family, isn't it? The definition is given like this. If there is a curve which cuts each and every member of a given family of curves by following a fixed condition, what will be the shape of that condition? It may pass through one particular point, or it may be inclined at a constant angle with each and every member, or it touches one more curve, like that. There must be a fixed point or a fixed condition rather. Let me repeat it. The curve which cuts each and every member of given family of curves by following a fixed condition is termed as, can be called a trajectory. That is the actual word, that is the actual meaning that can be given to the word trajectory. Why is it necessary to bring this into the frame? In straight lines, transversal is there, and in curves, trajectory is there. Both of them have similar qualities. Of course, here an additional condition is there. It must follow a fixed condition. What will be that fixed condition? It will be according to the context. Either passing through fixed point, or touching some fixed one, or cutting each and every curve orthogonally, like that. So, what is a trajectory? A curve which intersects or cuts each and every member of a given family of curves by following a fixed condition is called a trajectory. Is called a trajectory. And if that particular fixed condition is nothing but orthogonality, that is what I mean to say is, if this curve cuts each and every member of the given family of curves orthogonally, then such a trajectory is called an orthogonal trajectory. Is called an orthogonal trajectory of the given family of curves. Of given family of curves. That is the actual meaning of the word orthogonal trajectories. Okay then, we could have got the meaning of the word orthogonal trajectory. What will be the type of the questions generally be asked, and what must be the way to solve it? That we must know. It's enough for us. We need not go into the details of that one. What is an orthogonal trajectory? A curve which curves each and every member of given family of curves orthogonally is called an orthogonal trajectory. Okay, how to find the equation of an orthogonal trajectory? After knowing the definition, or rather the meaning of the word orthogonal trajectory, we now take interest, we now turn our head towards the method of obtaining an orthogonal trajectory. Hereafter, let me call it OT. OT means orthogonal trajectory. Let us understand this procedure by means of some steps. In the first step, Let the given equation of the family be f of x, y, c is equal to 0. You take the given equation of the given family. Second step, you obtain differential equation of the given family by, of course, eliminating the arbitrary constant f of x, y, dy by dx is equal to 0. Is the DE of given family. Now, actually we require the orthogonal trajectories, isn't it? Now, one of the most important suggestions given to us in theoretical is you just replace dy by dx by minus dx by dy is the DE of OT of the given family. Understand this step carefully, my dear. Dy by dx has been replaced by minus dx by dy. How do you agree with that? How do you suggest this? How can you understand this style? Actually, we want to have orthogonal trajectory. Let this be the given curve, let this be the given required orthogonal trajectory. What is the condition required? These two must be orthogonal. When can you say that two curves are orthogonal? When and only when the angle of intersection is 90. Okay then, how to find the angle of intersection? Slope of the tangent, dy by dx. Slope of the tangent, dy by dx. Isn't it? The product of these slopes must be minus 1. So, if this is dy by dx, automatically this will be minus dx by dy. So, that is the shortest way or the shortest route, the way or route to have the differential equation of the OT. It is not directly the orthogonal trajectory. Solving this equation, we require we get the orthogonal trajectory. Call this equation 1. That is, of course, the fourth step. What is the fourth step? Solving 1, we get the required OT. Required OT. Well, my dear friends, let us have a brief revision of this topic. What is meant by an orthogonal trajectory? First of all, a trajectory means a curve which cuts each and every member of a given family of curves by following a fixed condition is a trajectory of the given family. And if that fixed condition is nothing but orthogonality, that is what I mean to say is, if a curve cuts each and every member of the given family of curves orthogonally, then it is termed as an orthogonal trajectory. That is the meaning of the word. Okay then, how to obtain the equation of orthogonal trajectory? There are some 4 steps. Of course, they are very simple steps. In the first step, we observe equation of the given family of curves. I name it to be f of x, y, c is equal to 0. After taking that equation, you eliminate the arbitrary constant. Generally, arbitrary constant will be there because not a single curve is given to you. A family of curves is given to you. So, automatically an arbitrary constant will be there. You eliminate it and obtain the differential equation. I think you know the methodology. At the very beginning of the chapter differential equations, we could have discussed with the heading formation of differential equation, isn't it? Using those methods, the such methodology, you obtain the equation of differential equation of given family. Next step is the crucial step, very important step. Now you replace dy by dx by minus dx by dy. Thereby, we will be getting the differential equation of the OT of, what it means, orthogonal trajectory of the given family. Of course, by solving which, we have the required orthogonal trajectory. This is the process of getting the OT, that is a orthogonal trajectory. And it will be made clear if we can go through some examples or some special problems which were asked in previous question papers. We shall now going to do that. Observe the question. What is a given family of curves? X square minus y square is equal to a square. What is to be done actually? That is, what is required? What are you asked to have? Given family of curves is x square minus y square is equal to a square. Next step. Eliminate a and find the differential equation of the family of curves. Next step, replace dy by dx by minus dx by dy so that d of the OT will be obtained. And next step, solve it, OT will be obtained. That you have to take as y is equal to f of x. Automatically in the equation of OT, a constant will be there. In order to find that constant, use y of 1 is equal to 1. Using this, obtain y at 2. See, the process may appear so lengthier, but once you proceed, procedure will be so simple. You can look at, come on. Given family is x square minus y square is equal to a square. As we could explain previously, the first step is over. We have taken the given family. Differentiate it with respect to x on both sides. 2x minus 2y y1 is equal to 0. That is, x minus y y1 is equal to 0. Second step is also over. What is this? Let me call this 1 is the DE of 1. What do you mean by DE? Differential equation. You observe this step, next step, that is a crucial step, that is an important step in finding OT. What is to be done? Here by y1, what can we mean? dy by dx. This must be replaced by minus 1 by y1 is equal to 0. That is, this is the DE of OT of 1. Third step is also over. Now the next step is to solve this. So x plus y by y1 is equal to 0. That is, x plus y dx by dy is equal to 0. y1 is dy by dx. By y1 is appearing here, so we must take dx by dy is equal to 0. Or x dy plus y dx is equal to 0. That is nothing but d of xy is equal to 0. On integrating that, we have xy is equal to c is the OT. Okay, successful. We could have applied all the 4 steps. In the beginning, we have used one sentence. The process, the steps, the methodology may look so longer, but you see, the procedure is so simple. We could have applied all the 4 steps. That is the OT. Now, what remains here to show is use this to get C and then find y at 2. But y of 1 is equal to 1 implies 1 into 1 is equal to c, or c is equal to 1. As c is 1, we see that the curve is xy is equal to 1. You know that it is a rectangular hyperbola. Yes, xy is equal to 1. Could you recollect the standard form? What is xy is equal to 1? It is just nothing but rectangular hyperbola. Okay, right. What is required here? Y at 2. If x is equal to 2, then what happens? 2 into y is equal to c, but c is 1. Hence, y is equal to 1 by 2. So what is the answer? What is y at 2? Is nothing but half. Therefore, y at 2 is equal to half is the right answer. Well, my dear friends, you follow the procedure very carefully, even though it looks that it is a procedure containing 4 steps. 4 steps are four rules of procedure. The application is so simple, so simple. Y of 2 is equal to half. And if you are asked to have the orthogonal trajectory only, then it is xy is equal to c. Xy is equal to c. Of course, with this given information of y of 1 is equal to 1, we have seen that xy is equal to 1 represents a rectangular hyperbola. Okay, right. Let us look at one more such question. Another question is before us. The orthogonal trajectory of the family of curves x square plus 2y square minus y is equal to c is, its equation is giving y is equal to cx square plus k. Then what is k? What is k? He is asking us. Okay, let us follow the methodology. The series of steps. What is the first step? Given family is x square plus 2y square minus y is equal to c. First step is over. Differentiate it with respect to x. 2x plus 4y y1. What do you mean by y1? dy by dx minus y1 is equal to 0. Enough, the constant has been eliminated. It is nothing but the dE of the given family. Let me simplify this. That is y1 into 4y minus 1 plus 2x is equal to 0. Second step is over. What is this? Is the dE of 1. Second step is over. What is the third step? Very important and crucial step. What is to be done here? What is to be done here? This y1 must be replaced by minus 1 by y1. Why? Because dy by dx is to be replaced by minus dx by dy, and thereby y1 must be replaced by minus 1 by y1. What happens? Minus 1 by y1 into 4y minus 1 plus 2x is equal to 0. Is the dE of OT of 1. Therefore, 2x is equal to 4y minus 1 into, this goes that side. y1 is dy by dx, 1 by y1 is dx by dy. Dx by dy. Third step is over. What is this third step? We could have got the differential equation of required OT. And look at that. We should feel happy, my dear. This is in the form variable separable, isn't it? Okay. Therefore, dy by 4y minus 1 is equal to dx by 2x, isn't it? Dx by 2x is equal to dy by 4y minus 1. And on integrating it, what do you have? Log mod 4y minus 1 by 4 is equal to half log x plus k. Another constant you have to use, isn't it? Plus k. Okay. Multiply it with 4. What happens? Log of 4y minus 1 is equal to 2 log x plus 4k. Plus 4k. Instead of k, let me write some log c1. Instead of k, let me write log c1 by 4. Now you multiply it with 4. What happens? Log 4y minus 1 is equal to 2 log x plus log c1. Therefore, log 4y minus 1 is equal to, this is log x square, that is log c1, log c1 x square. Remove the logarithms on both the sides. You will be having 4y minus 1 is equal to c1 x square. Isn't it? Okay. From that, 4y is equal to c1 x square plus 1, or y is equal to c1 x square by 4, c1 by 4 plus 1 by 4. Of course, you can compare this with the given equation. Of course, this c1 by 4, in the place of c1 by 4 we have c, and in the place of k we have 1 by 4. What is the value of k? 1 by 4. What is the value of k? 1 by 4. Because this has been obtained by solving the differential equation of the OT, but not of the given family. Therefore, this is the OT, and this can be compared with the given equation, so that k is equal to, what is k? 1 by 4 is required. Like this, we have the equation of orthogonal trajectories of the given family of curves. There are two more beautiful examples. We shall be looking at those examples now. Another beautiful problem is before us. Understand the question very carefully. The orthogonal trajectories of the family of curves y is equal to cx square. I think you could have recollected that y is equal to cx square represents the family of parabolas, or conics with eccentricity is equal to. Nobody knows. What will be the equation of OT? Will it be an ellipse? Will it be a parabola, or will it be a hyperbola? No problem, it might not be a parabola, because if it is a parabola, he might not have asked us E. In the case of a parabola, eccentricity is 1, you know. So, the answer would be either an ellipse or a hyperbola. We shall be looking at. Okay. Let us first have the equation of the OT, by observing which we can calculate the eccentricity. No problem at all. Let us apply the series of steps. The first step, what is the family? Y is equal to cx square. The second step, obtaining its differential equation. Differentiate it with respect to x on both sides. y1 is equal to 2cx. Isn't it? This by this implies y1 by y is equal to 2cx by cx square. That is 2x by x square is 2 by x. 2 by x implies y1 is equal to 2y by x is the differential equation of the given family. Well, my dear, how many steps are completed now? We have taken the family and have produced the differential equation. Why should you do all this? You are supposed to eliminate the arbitrary constant. Then only we will be having the equation, differential equation of the given family. Only 2 steps have been fulfilled. Let us now look at the third step, which is the crucial step. What is that? You are supposed to replace y1 by minus 1 by y1. Implies minus 1 by y1 is equal to 2y by x is the differential equation of OT of 1. y1 is dy by dx, 1 by y1 is dx by dy. Implies minus dx by dy is equal to 2y by x, or x dx plus 2y dy is equal to 0. Is equal to 0. So that its equation, if you integrate it on both sides, x square by 2 plus y square is equal to c. This looks like an ellipse. X square by a square plus y square by b square is equal to 1. You see, it is a family of ellipses. It is a family of ellipses. The particular solution is x square by 2 plus y square by 1 is equal to 1. By taking c is equal to 1, you will be having an ellipse. So this is a family of ellipses. In the case of an ellipse, what is the formula for the eccentricity? 1 minus b square by a square is equal to 1 minus 1 by 2 is 1 by 2. Hence, E is equal to plus or minus 1 by root 2 or 1 by root 2. Eccentricity is a ratio, it is positive, therefore 1 by root 2. So what is the eccentricity? 1 by root 2. This is one of the simplest problems. You may get a doubt. Who told you that this ellipse is x square by 2 plus y square by 1 is equal to 1? It is a member of the family, no? We are asked to have the eccentricity only, isn't it? Therefore, it is a family of ellipses with same eccentricity, hence E is equal to 1 by root 2. E is equal to 1 by root 2 is the required answer. Yes, in this also involvement of obtaining the equation of orthogonal trajectories is present. Yes, that's it. One more special problem in orthogonal trajectories is there. Consider the equation x square by a square plus lambda plus y square by b square plus lambda is equal to 1. This represents a family of confocal conics. Confocal conics. Here the parameter is lambda. So, if at all you want to have the differential equation whose solution is this, you are supposed to eliminate just lambda only. Well, the main question is, what is the equation to the orthogonal trajectories of the family of confocal conics x square by a square plus lambda plus y square by b square plus lambda is equal to 1. There is something special in the answer. We shall observe and enjoy this problem. Come on. How many parameters are there here? Only one parameter. So, what is the thing to be eliminated? Lambda. Hence, order of the differential equation which is going to be produced must be 1. That is, you can at most differentiate this equation on both sides once and only once. Only one time you can differentiate. Come on, do it. 2x by a square plus lambda plus 2y y1 by b square plus lambda is equal to 0. Here by y1, let us mean dy by dx. Let me call this equation 1, and this 2 can of course be cancelled, leaving you x by a square plus lambda is equal to minus y1 by b square plus lambda. B square plus lambda. Well, by making use of properties of ratios, we can use this as this is equal to x plus y1 by a square plus lambda minus of b square plus lambda is nothing but a square minus b square. I think you could have noted and recollected the formula from ratios. That is what I mean to say is, if at all you have two ratios of the form a by b is equal to c by d, then each of these ratios is equal to a plus c by b plus d, and it can also be made equal to a minus c by b minus d also. As of course, I could have made use of that. So that we have x by a square plus lambda is equal to minus y1 by b square plus lambda is equal to x plus y by 1 by a square minus b square. Well, my dear, our actual purpose is to have the orthogonal trajectories of the given family, and in that business we could have completed just one step only. taking the given equation. We have not yet produced the differential equation of the given system. Here we are to eliminate lambda from this equation. Now from this equation 2, we have 1 by a square plus lambda is x plus y 1 by a square minus b square 1 by x into. Similarly, in the place of 1 by b square plus lambda, you will be able to have some expression. Okay, we make use of those two expressions to get substituted in equation 1. Now, eliminating a square plus lambda and b square plus lambda in 1 using 2. We are to eliminate 1 by a square plus lambda and 1 by b square plus lambda, or rather a square plus lambda and b square plus lambda from 1, making use of 2. Here 1 by a square plus lambda is present, x square into, in the place of 1 by a square plus lambda, 1 by x into x plus y 1 by a square minus b square plus y square into. In the place of 1 by b square plus lambda, what can you have? 1 by b square plus lambda, minus y 1 goes this side, minus 1 by y 1 into x plus y 1 by a square minus b square is equal to 1. Well, here 1x will be cancelled, here 1y will be cancelled. Let me multiply throughout by a square minus b square. What happens? X into x plus y 1 minus y by y1 into x plus y 1 is equal to a square minus b square. Okay, good. Again, we can have x plus y 1 as a common factor. X plus y 1 into x minus y by y1 is equal to a square minus b square. Well, my dear, let us have a revision of this problem from the beginning. This is the given family of curves. The only parameter present here, it is lambda. We are supposed to eliminate lambda. That is, we are permitted to use the process of differentiation once and only once. Okay, we have done this. By using the properties of ratios, these two ratios are equal to this. Okay, from this 1 by a square plus lambda is equal to 1 by x into this quantity. 1 by b square plus lambda is equal to minus 1 by y 1 into this quantity. Okay, at last we could have arrived at that particular step. What is this step? In the process of getting orthogonal trajectories, how many steps are so far completed? Just 2 steps. What are they? Taking the given system and obtaining its differential equation. You see, this is the right spot at which a miracle is going to be observed. What is that miracle? Let us see. To have the differential equation of the orthogonal trajectory, replacing y1 by minus 1 by y1, what happens? X minus y by y1 into minus y into minus 1 by y1 is into x plus y y1 is equal to a square minus b square. That is the miracle that we are supposed to observe. Is there any difference between these two? Observe it carefully. X plus yy1 into x minus yy1 is equal to a square minus b square. X plus yy1 into x minus yy1 y by y1 is equal to a square minus b square. What can you conclude by observing this similarity? This scene, or rather this context, reveals that the given family of curves and the orthogonal trajectories have the same differential equations. The same differential equation they have. As their differential equation is same, their solutions will also be same. Therefore, in such a case, we say that the given family of curves is self-orthogonal. Is self-orthogonal. Such things may occur. Even in the case of straight lines, you see, you observe there are two perpendicular lines. Imagine. Find the pair of lines passing through the point of intersection of these two lines and perpendicular to themselves. Same pair will be obtained. So, this is self-orthogonal pair of lines. Just like that, this is self-orthogonal confocal conics. Such things rarely occur, isn't it? Therefore, this system is simply self-orthogonal. Yes, that is what we mean by self-orthogonality. That is, if at all you try to find the equation to the orthogonal trajectories of the given family, the differential equation of the orthogonal trajectories and the differential equation of the given family, they coincide. You need not proceed further, isn't it? In such a case, we say that the given system is self-orthogonal. This is the matter about orthogonal trajectories.